This is for the observations. For example, test of iron 3 ion, and then they would like you to give an observation. Some students, they will write chocolate precipitate is produced. This is not correct. Okay, if you write this in your exam, like, you won't get any mark. You won't get any mark because you cannot use the word chocolate. So what's the words that you should use instead of chocolate? Brown. Brown precipitate is produced. Okay, use the correct color. Okay, use the right color. Don't use chocolate. Chocolate is not a color. A stable atom. Now, sometimes and the question they ask, why group 18s they exist as monoatomic gas in nature. So some students, they give the answer that because they are very stable, or that the atom is very stable, and this is not an acceptable answer. Okay, so what's your suggestions? Instead of stating that the atom is stable, what's your suggested answer? Okay, so should it say because their outermost shell fully filled with electrons? Okay, the outer shell has filled with the maximum electrons. That's good. Try to use the word octet and duplet instead of stating that they are fully filled with electrons. Fully filled. Try to avoid this. Fully filled. Okay, or achieve maximum, filled with maximum electron. Another one is filled with electrons. Priscilla say reach stable electrons arrangements. Stable electron arrangements. Okay, now the third one is totally unacceptable. Okay, you wouldn't get any mark for it, because you must tell why is it stable. Okay, why is it stable? And it's stable because it achieves octet or duplet electrons. Now for these two, sometimes the teacher may still give you correct, but actually they are not accurate. They are not accurate. So why? Because the first shell, okay, first shell, it can fill with maximum 2 electrons, right? Okay, maximum, okay, it can fill with 2 electrons. How about the second shell? 8, right? How about the third shell? The third shell maximum can fill 18 electrons. How about the fourth? 32. Okay, but it will be stable if the first shell filled with 2 electrons, the second shell filled with 8 electrons, the third shell filled with 8 electrons, and the fourth shell filled with 8 electrons. Now when it filled with 2 electrons, we call that duplets. And when it filled with 8 electrons, then we say is octet. So therefore, if you say fully filled with electron, that's not correct, right? Because you see, this is not fully filled. The third and the fourth shell is not fully filled. They just achieve octet and they become stable. They achieve octet, they become stable. Not necessarily it must be fully filled, and not necessarily it must fill with maximum electrons. So you should say it achieve octet or duplex electrons arrangements. Okay, I didn't say this is wrong. Okay, so most of the time, okay, your teacher accept this answer, the marker. But as I always say, we can't guarantee that this year they will still accept this answer, because this answer is not, we can't say not correct, but it's not accurate. Okay, so I suggest that you give this answer, octet or duplex electrons arrangements. Don't say it's stable, okay, or stable electrons arrangements. That is not enough. This is okay, it's not wrong, but it's not enough for you to get mark. Melting point is the point where solid changes to liquids. Okay, if you write this in exam, you won't get any mark. You see, the problem here is the point. It shouldn't be a point. It should be temperature. So melting point is the temperature where solid changes to. So the point here actually is the temperature. Solid to liquid or solid state to liquid state, that one is fine, okay? That one is fine. Okay, this is for the solutions. For the solution, they say a clear solution formed. This is not the correct words to be used. And instead, what should be the words used? Clear solutions, colorless. Okay, don't use the word clear solutions. Instead, use colorless solutions. The rate of reaction for experiment 2 is faster or slower than experiment 1. Okay, so this is also not correct. So any suggestions for the corrections? Higher or lower? That's correct. Okay, so for rate of reactions, you can't say it's fast or slow. Cannot. Okay, fast or slow. We have fast or slow experiment, but we don't have a fast or slow rate. So you must tell it's a higher or lower. So this is not correct. Okay, this is correct. Nucleus contain 1 proton number and 1 neutron number. So this is to describe the nucleus of an atom. It contains 1 proton number and 1 neutron number. Number of neutron, yes, okay. It shouldn't be proton number or neutron number, okay. It should be proton or neutron, okay, or a number of proton or number of neutrons. Okay, so just proton and neutron, okay. So nucleus contain 1 proton and 1 neutrons, okay. So don't use a number. Use a number, okay. Proton number is the number of protons, and we don't use the word neutron number, okay. It's a nucleon number. Nucleon number shows the number of nucleon, which is the sum of proton and neutron, okay. And this is correct. This is when you explain the formations of sodium ions, the formations of sodium ions. So sodium, it donates electrons, it becomes a sodium ions, okay. So sodium donates electrons and form sodium ions. Okay, now if you write this, you won't get any mark for it, okay. This is in the explanations of the formations of ionic compound. So what's the suggestions for the corrections? Release or throw. Okay, never mind. The word donates are not the problems, okay. So you can use the word donates, okay. There's proper words to use. Donates. Release or throw is also acceptable. You see the correct words. You must tell that there is a sodium atom donates 1 electron. So you see, sodium, okay, is not specific enough. You see, in chemistry, I always stress that your answer must be specific. You cannot say sodium, okay? Sodium what? Sodium ions, sodium atoms, sodium metals, sodium what? Sodium gas, okay? Sodium atom, okay? Donates how many electrons? You must state. Donates 1 electron. So you see, when you write your answer, you must be specific, okay? Sodium atom means sodium atoms, okay? Don't write sodium. Magnesium is more active than zinc. This statement is not correct. So what's wrong with it? Reactive, that's correct, okay? So we shouldn't use the word active, okay? For chemicals, we use the word reactive instead of active. So you should use the word reactive, okay? Okay, ECS. You shouldn't use ECS. Instead, you must write electrochemical series. So when answering questions, don't use short form, okay? Don't use this shorthand or abbreviations. In the electrochemical series, magnesium is more reactive than zinc. So if say electropositive, okay, that's correct, okay? Now in electrochemical series, then you must state that it's more electropositive, okay? In electrochemical series, it's more electropositive. Electrochemical series is obtained by comparing the voltage produced, okay? The voltage produced by a chemicals when compared to hydrogen, actually. It's compared to hydrogen. So therefore, it obtained from this electrochemical cell. Okay, electrochemical cells, and then it compare which atoms or which elements are more electropositive and which one is more electronegative. Okay, so electrochemical series compare electropositivity and electronegativity. Yeah? So when you use the word electrochemical series, then you must say it's more electropositive. Okay, more electropositive doesn't mean it's more reactive. Okay, there are a difference between reactivity series and electrochemical series. Okay, there is difference between them, and I think I have explained to you before, maybe last month. I don't know whether you still remember or not. Okay, there's a difference between these two series, even though they are quite similar, but they are not the same series. Okay. Okay, next one. In the reactivity series, magnesium is more electropositive than zinc, and this is also not correct. Okay, in reactivity series, then you must tell that it's more reactive. Okay, it's more reactive. So in reactivity series, then you shouldn't use the words electropositive. You must use the words more reactive. Potassium atom has a higher tendency to release electrons because it is more reactive. This is not correct. Why? It is more electropositive. Yes. Okay. So Hui Cheng say we should use the words electropositive instead of reactive. That's correct. Okay. Because for the tendency to release electrons, that is related to the electropositivity, not the reactivity. Okay, that's related to the electropositivity. So potassium atom has higher tendency to release electron because it is more electropositive. Okay, it is more electropositive, but not more reactive. Okay, the shell or atom is full or fully filled with electrons. This one is when you want to explain why an atom is stable. Hui Cheng say valence shell. Okay, that's correct. Okay, you shouldn't say the shell. Okay, you shouldn't say the shell. It's the valence shell. It's filled with 8 electrons. Okay, you see, I advise you to use the word full or fully filled. Okay, because not necessarily it must be fully filled. For example, the third shell fully filled is 18, but just 8 electrons, then it will become the most stable. Okay, Shuib asks, can we use outermost shell? Yes. Valence shells or outermost shell is filled with 8 electrons. Filled with 8 electrons. Don't use the word full or maximum. Okay, yeah, try to avoid that. Because that is not correct or not accurate. Magnesium achieves the stable arrangements. I think this one similar to what we discussed just now. Okay, so you shouldn't say it achieved the stable arrangements. Okay, this bring no meanings. What does it mean by stable arrangements? Okay, so you must tell that it achieved the stable octet. Okay, since it's magnesium, so you don't need to say duplet. You don't need to say duplet. Only those ions that has only one shell filled with 2 electrons. The first shell filled with 2 electrons, then it's duplet. But for magnesium, it achieved octet. So it achieved the stable, but just stable is not enough. Stable octet electron arrangements. Okay, so always remember octet electron arrangement, not stable arrangements. Argon is inert because it is in group 18. So same thing. Okay, with some students said that why argon is inert, because it's in group 18. Okay, that is not a good explanation. Okay, that's not a good explanation. So because it's monoatomic, no, that is the result. Okay, that is not a cause. Okay, we have cause and effect. Monoatomic is the effect, not the cause. Okay, so why neon, argon, helium, krypton, they are inert? Why? Octet, yes. Okay, you must say that because they achieve octet electrons arrangements. So it's inert because it has 8 valence electron, or it has stable octet electrons arrangements. Okay, again, you see here, I do not use the word fully filled or achieve maximum number of electrons in the outermost shell. Try to avoid that, okay? Use 8 valence electrons or octet electrons arrangement. Sodium has 3 shells, okay, or 3 electron shells, because we know that's the electrons arrangements of sodium. For sodium atom, the electrons arrangement is 281. Okay, 281. So then you say sodium has 3 electron shells, or 3 shells filled with electrons. 3 electron shells, sorry. Sodium atom, not a problem, okay? Actually, that is not a mistake, okay? Sodium atoms, okay, you use sodium, okay, sodium atom is okay, but that is not a mistake. So what's the mistake here? Sodium atom has 3 electron shells, or 3 shells. Sodium has 3 electron filled shell, or 3 shells filled with electrons, okay? And then that's correct, okay? You shouldn't say it has 3 shell, because actually it has more than 3 shell. It can has a 7 shell. Sodium has 7 shell, but just the first 3 shell filled with electrons. Okay, so for sodium, it has 1, 2, 3, 4, 5, 6, and 7, okay? And only the first 3 shells filled with electrons, okay? It actually has 7 shells, but only the first 3 filled with electrons. Now, only the first 3 filled with electron doesn't mean that the 4th, 5th, 6th, and 7th shell doesn't exist. They are still there. The shell is there, but it's not filled with electrons. Okay, so if you heat sodium, okay, so this electron, it may jump to the 4th shell, okay, and move inside this 4th shell, okay, and if you heat it more, then it will jump to the 5th shell and move in the 5th shell, okay. So this electron can jump to the outer shell, okay. Yeah, so if you heat it, so you see, it doesn't mean that if 3 shell filled with electron, then it only has 3 shell. It has 7 shell. It actually has 7 shell, but some of the shell, especially those shells outside, okay, is not filled with electrons. So if you say sodium atom has 3 electron shell, that's not correct. Okay, it has 3 shells filled with electron, and then that's correct, or 3 electron filled shells. Okay. Sodium or sodium ion release electrons. That's not correct. Is because, okay, you must tell that one sodium, it must be sodium atom, okay? You cannot use sodium ion or sodium. Don't use the wrong words, okay? Don't use the wrong words. One sodium atoms releases 1 valence electrons, okay? Not release electron. How many electrons? Which electrons? You must tell, okay? So it released 1 electrons. Which electrons? The valence electrons. That is the electrons in the outermost shell. Okay, and to form sodium ions. Okay, so you see, you must tell that it's a sodium atoms. Okay, and it released how many electrons and which electron it released. The valence electron it released. So this is to explain the formations of the ionic compound. So this is the words that you should use. Okay, the force of attractions between the nucleus and the valence shell or the outermost shell is strong. This usually is used to explain the reactivity, reactivities of group 1 and group 17. Okay, group 1 and group 17. So the reactivity is affected by the force, okay, between the nucleus and the valence shell. Okay, but if you write valence shells, then that is not correct. Okay, Xinyi suggests that we should use valence electrons instead of valence shell. Okay, that's correct. And Shuib say we should use the word electrostatic force. That's also correct. Okay, but if use force is okay, birth force and electrostatic force is also acceptable. That one is not a problem. Okay. Now it's force of attraction. These are no problems between the nucleus and the electrons in the valence shell. Okay, or valence electrons. Electrons in the valence shell means the valence electrons. Okay, or the outermost shell. Okay, is strong. So you see that is the force between the electron and the nucleus, not the shell and the nucleus. This one they say the force is between the nucleus and the shell, and that's not correct. Okay, it's electrons and the nucleus. The force is between electrons and nucleus. Okay, and the electron is the valence electron, or the electron in the outermost shell, or electrons in the valence shell. Transition metals are color. Okay, so this is to describe the special characteristics of transition metal. So transition metals are color, or transition metals has color. Okay, so if say we should use the word transition element, transitions element instead of transition metals. Any other suggestions? Okay, Hui Chang say we should use the word color ions. Color ions. Okay. Okay. Now transition itself, all the transitions metals they are gray. The color are gray. Like all other metals, they are gray. But their ions have different color. The ions have different color. Okay, the transition itself just normally just gray, dark gray, or these are bright grays or light grays, or okay. So because they are metals, they have shiny surface and a grayish, this is a grayish surface. Okay, but their ions, okay, and the ions can form compounds. So the ions and the compounds are colored, not the metals. Transition metal is not colored, but the ions or compound is colored. But if you say transition elements, don't use the word metals, okay? Transition elements are color ions, and then there's okay. Okay, transition elements are colored ion, or they have color ions, then that's okay. Okay, so always remember, for transition metal is the ions or compound they have color, but not the transition metals or transition element. The transition metal and transition elements, they're just gray in color. Okay, like for example, iron is gray in color, but iron 2 is green and iron 3 is brown. So iron 2, iron 3, there are the ions of irons, or maybe they form salts, then they are still green and brown color. Okay, so that are the compounds. So it's the ion and compounds that have different color, but the metal itself, it don't have different color. Ethanol does not conduct electricity because it is covalent compounds. That is not correct, and the correct one should be ethanol does not conduct electricity because it consists of molecule and does not have mobile or free moving ions. Okay, and the important words here is it does not have free moving ions. But whether it's a van der Waals or not van der Waals force, that one is it doesn't affect. Okay, it doesn't affect.